what we're going to do real quick, we're going to explain to you what's going on back there, and then we're going to take you back there and let you see it in action. We're going to let some of you going to actually get to do some of it. Be sure if you got any questions to ask, and we'll come back in here at the end, and you can ask my team as many questions as you want. But before we start with that, I want to ask you guys a question. How many of you guys love to eat? That's what I'm talking about. Yep. Listen, teaching high school students, they love to eat. You keep them fed, they're happy. So let me ask you this. Do you know how many of you know where your food comes from? Okay, where does it come from? From farmers, right. We grow our food, but we've got a little bit of a problem. Can I tell y'all a secret? We're running out of farmland. Yeah, so here's what's happening. Because we have so many people and we have so many things we got to have, we're building homes, McDonald's, Walmarts on all of our farmland, and we're losing it. So we still have to eat, right? Still got to eat. So what we're starting to learn is we can actually grow our food in buildings, in greenhouses, and we can provide that food that we're going to miss out on by growing it indoors. But it's a little bit harder indoors because what don't we have indoors that we do outdoors? Exactly, good job. We don't have the sun, we don't have rain, and we don't have something else. Soil, there somebody said it, yeah. So we don't have those things, right? So to grow plants, you've got to have sunlight, soil, and water. So what we do here is we actually grow all those things, but we create that environment for them artificially, okay? So what we're going to do, Braden is going to kind of explain to you back here what it's about, but before we do that, when I said he was one of the original members, my freshman about 3 years ago came up with this idea that they wanted to grow food for their friends and teach them how to grow their own food. Now, my students make food for our high school. So when my students or our high school students go through the lunch line and they eat lettuce and stuff, my group grew it for them. So everything we grow back here goes to our cafeteria, and our students eat it. So they know where their food comes from, how safe it is, no pesticides, no herbicide, no nothing, and they do a really good job.
Started this year, and it's been pretty amazing learning about this stuff.
I came here as a freshman, and we got really interested in the hydroponics system, which ended up growing into a whole STEM lab with aquaponics, hydroponics, and aquaculture systems.
I have been a part of the Aquafood program since it started freshman year, so Lord have mercy, that was 2019, I think, before COVID. And so we've been, at first it used to be a storage room with a bunch of junk, and now it's cleared out thanks to us, my class, and some more people who went through some weird stuff. You never thought you would find some stuff in an ag room, but you do. And so we cleaned everything out. We started with our first Nft System, which was our lettuce production and stuff that we took down from the greenhouse to bring up here. And then about, I would say, a month or two ago, we got a new one, and then we've only grown from there. We've got grants and donations and colleges that help us out, and universities that now have made Aquafood what it is.
What we do back there, there are three things we mainly do back there. We have hydroponics, aquaculture, and aquaponics. So these are the systems that we use to produce our lettuce. We could produce tomatoes, we could produce any vegetable really, and honestly fruit as well. And so if that's what we use for, like, in some cases, I'll talk about it with hydroponics, that we use it basically on water. We'll use if it has fish in it, we actually use the fish doo-doo to make it into the food that it eats. Hydroponics is basically, you know how you have to have soil? That's what everyone says, you have to have soil to make a plant grow. That can be wrong. It's right, you can use soil, but we can also just use water to make a plant grow. we actually have an Nft system, which is at a slant. And so what we do is we put running water and we add a little bit of nutrients. So that is basically, we add food to it that when the water goes down, it goes down the little gutters we have, the plant sucks it up. And so each plant gets a lot of nutrients, and so it's always constantly getting fed. And so the best part is, how many of you have been to a buffet and you have ate and you've eaten so much that you cannot eat anymore? Like you have a full plate and you can't eat. I have. I definitely have. That's what a plant will do. So if we put too much food in there, guess what it's going to do? It's not going to eat. Sometimes, it may get too much nutrients, it might die. But it just will not accept that food that we're giving them. So what we do is, every day, when you go back there, you'll see a big TV and you'll see a bunch of numbers. And I know you'll be like, what the heck are these numbers? I have no clue what they mean. That is how we can tell how much food is in our water. So we actually have a big system and tiny systems we call shoebox systems, because it's roughly the size of a shoebox. And so basically we use that, and that's what we started with Aquafood, is we used a hydroponic system. So that way we can grow lettuce, and when you go back there you'll see some lettuce that we're growing, but it makes it so amazing and just like it's so fresh. And like, how many of you, when you eat a salad, you want a crunchy salad? You don't want no soggy salad. That's disgusting. Yeah, we have, when we did our harvest, it is so fresh and you have that crunch and it tastes so good. And so so when you go back there, you will have to cover your eyes for a second because it is so bright back there. You know why? We actually use light and we use it instead of the sun. Because do you think we get sunlight through that room?
No. Yeah, totally.
Really?
Yep.
We can get it through the window, but not really. We don't have a big sunroof where we can get sun, so we use light. And so what that light does is, with plants, with the sun, it produces rays and a UV light. So it takes some of that light that it needs, so they actually make lights for that, LED lights, that gives that same stuff that a plant needs. So when you go back there, you'll see these bright lights. And so that's actually helping the plant grow because that's their sun. And so when you get there, and you'll see, like, why are they so low? It's because that's how much of that it gives off. So when it's lower, it actually helps it grow better. So next, we'll talk about, aquaponics is basically like the hydroponic system, but there's fish in it. So when we do that, instead of just using nutrients for that water, we actually use fish manure, which is basically fish doo-doo. And so we actually use it, and it goes through a filter, and it gets all the bad stuff that we don't need. And it takes it, and we get the stuff that it does need. And so it flows through the grow bed, which is what the plants are sitting on. They're sitting on like a boat of water. And so it helps it grow, and it sucks that nutrition in like a hydroponic system. And then everything that's left over, it just cycles right through, and it keeps going. And so when we feed the fish, and you'll go in there and you'll see the water and it's not clear, that's actually a good thing. That means that it's producing nutrients. It's producing that food so the plants can eat it. So now, aquaculture, you know how I talked about we've been using water and fish? And so we use nutrients from the water. With aquaculture, we are just using fish. So we are actually, we are growing fish and we're raising fish, and we're not going to produce any vegetables and stuff, but we're going to produce fish to eat. So basically what we do is we have tilapia back there. And so we grow these tilapias from little babies. So when you go in our first system, you maybe see one. They're usually at the bottom, but there's a little tiny fish. It's kind of like the fish you have when you go to like Walmart or someone you buy a little pet fish. That's how about size they are. And so then they grow and they grow and they become these huge tilapia fish that when they're ready to harvest, we'll actually take them out and we'll get it ready so we can give it to places like Warm Blessings, which is a soup kitchen that we help feed people who don't have homes or don't have access to food and don't have that stuff that you really need to survive. So that is what our Aquafood Lab consists of. And so all those things together, we are able to feed our peers, our friends. So, some people that are next to you, you never know. Someone next to you might be, they don't get enough food at home, and it's not their fault. It's just how stuff is. And so what we do is when they come to school, we want to make sure they get food. You all are going to go actually see our systems. You're going to talk to our amazing people you met over here, and you're going to see some fish.
Those perspectives of like seeing those kids that are not in agriculture come in, it opens your eyes. It's like, at first, everyone says agriculture kids are those country kids. They got boots, they got hats. That's the stereotypical that we get. But with how urban we are in Elizabethtown and Radcliffe, we have a lot of diversity here at John. And so when we first started, we actually had a kid come in, and she was just like, no one knew her, like, because we were like, hey, how are you? Or, is there something you need or anything? And she was like, yeah, it's okay. I was coming to see the fish, and I was coming to see the lettuce, and you all grow that stuff. And so after that, more people came. And it was like, once we started getting out there, they were just all intrigued of how it works, because we taught in science that a plant grows in the ground with soil in the rain. But opening that new world of like, it doesn't have to be soil for a plant to grow. It can be from just water and nutrients. It can be from, fish waste, and it can be from fish. And I think it opened their eyes and opened our eyes of what we're seeing this economy grow and this, community grow into this agriculture-based world, which is already happening but was lost for so long. And so now it's coming back, and it's great to see that.
What piqued my interest is honestly, how quickly you can produce this food. Like, this could solve so many world hunger problems, and just it can basically fix our problem that was coming up in 2050.
These are our newest systems. These are aquaculture systems where we just grow fish. Now, this tank is about a 500-gallon tank. And in it right now, we have about 200 small fish called tilapia fingerlings. As the fish eat, they give off ammonia, they give off poop, right? And you don't want them swimming in that. So it comes out this pipe and it goes into this. This is called a bead filter. There is about 1.5 million little small plastic beads in this big green tank. This is just some of them, okay? You can kind of see what they look like, okay? They're just little small plastic beads. We got over 1 million of them in here. Now, what they do, they serve two purposes. So as the water goes through these in this big green monster looking thing here, all the fish poop, the solids, it gets caught by these beads so it can't go on through. And that keeps it from getting back into the tank. And we have all kinds of really good bacteria that live on these, and it actually takes that fish food, all that ammonia, and turns it into good stuff so we can feed back to the plants. So what happens is all that collects in this unit. After about a week, and you won't be able to see it because I just cleaned it for them, but this little knob will turn it on, and you see that stuff going through there? Okay? That's going to dump into this tank. And this tank has nothing but fish poop. Fish poop and water is what's in it. So we have this stone that puts out air, and it actually mineralizes what's in here. After about 5 days, we can actually come back here, we'll dump it into one of our buckets, and it's fertilizer that the plants love. So it's all natural. So we take the fertilizer we make out of the fish poop, and we put it in our plants, and we don't have to pay for buy any type of fertilizer, and this is all natural fertilizer, okay? So it works really well.
What we have done in this program, I was actually a part of the progress to get these actual tanks in. It was the All Tech Challenge. We talked about how 2050 is going to affect us and everyone else, and how that if we, as a FFA chapter, got these tanks, we would be able to produce enough food and nutrition for our community. And not only that, but further our experience and knowledge. And it would help us understand how to create food for 2050.
My first year was the first year that we started the lab. We started off with hydroponics because it is more simple. it's where you grow plants without soil. So you can have it in your bedroom, you can have it anywhere you want. You have to just make sure that your water has the nutrients that your plants need, and everything will go well. But my first year, we tried to do the All-Tech Innovation Challenge, and we came 4th that year. So we kind of learned the basics of what that challenge entailed, and whenever we put it all together with our new challenge group that won this year, they won the $10,000 grant and enabled us to get our aquaculture systems, which is where fish grow, and we'll take the fertilizer from the fish and put it back into the hydroponic system. So then we don't have to keep purchasing nutrients for the hydroponics. It just comes straight from our fish.
I have been with it because my dad's the ag teacher, so I've been with FFA ag, since I could walk and talk. I was here when I think it was 2015 when my dad first started at John. There was a group that wanted to try and do this. They had the best plan and they grew, and then they left, and then no one else took care of it. And then seeing that being revived is such an amazing thing. It was just like light to my eyes, because it's so amazing that now we have over at Bluegrass, we have a middle school ag program, and I was talking to them about it. They come in and it's amazed. They're putting posters out in the school talking about, hey, do you need help with this and stuff? Come talk and we'll help you get proper nutrition. We'll make it work for you, because they have the school lunches they give for all the kids who need them at home, but if a lot of that stuff isn't always fresh and all, for that, especially for the weekend, it doesn't last that long. So if we can give that to our community, that's something that I've loved to see over the course of years. That ag, you have all these programs and electives that tell you you're a family, but ag and FFA have always been a family without a doubt. You always have people behind your back and always have them ready with you.
So this is our aeroponics tower. And basically this is entirely just misting the roots of the plants with a nutrient solution. So we have a really big tank down here, and there's the aerators in it, so it's constantly being aerated, and the nutrients in the water are constantly moving. And so then there's a tube that comes all the way up, and it's constantly just dripping this nutrient-rich water, misting, same difference. You're misting it onto the roots of the plants. You can grow lettuce, strawberries, a bunch of different fruits, and just a lot of different plants with it. It's really tricky. The nozzles tend to get really stuck, and it's a mess, but it does grow pretty efficiently when you get it to work correctly. I haven't actually gotten to grow anything with it, but I think you guys did first trimester. Yeah. So at the beginning of the year, they actually got stuff to grow with it, and they were able to harvest out of it.
Aquafood is a STEM lab where students conduct research and have experiments of their own with aquaponics, aquaculture, and hydroponics. And we actually give the lettuce back to the school for school lunches, and the fish end up going to Warm Blessings as a sustainable protein source.
Anyone can do this. Anyone with the knowledge of it, which I suggest that, it's pretty simple knowledge. That basically plants need structure, which we use rock wool for that, and obviously they need water and they need nutrients, which water and nutrients, you can combine those two into one and feed plants and filter them out like that. Obviously there's more to it, but that's the basic simple form of it.
It's really easy to get the hang of once you get the hang of it. You can have smaller systems that you can have in your house. They can be DIY, or you can order them commercially, and you can grow your own sustainable food.
Aquaponics, hydroponics, you can do this anywhere. You can do it in your backyard, your house, your basement, your attic, anywhere. Just as long as you have the knowledge about this project, you can basically make it into your own source of food, income, anything. And it's a big world problem solver.
This is our Nft system. You see right here, these are our little lettuce plants. See, what Brayden was talking about earlier with you in the classroom, these are the systems that have like a slight angle, and this is all the plants where they take up all the water and nutrients and they suck it up. So after they suck up all the nutrients and water, they actually start to get bigger, and they start to get, and like, have you ever seen the big heads of lettuce at Walmart in like the little plastic containers? Yeah, this is what these will turn into. And if you ever have like school lunch and stuff, and you have like a lettuce or salad or anything, this is the type of lettuce that we're growing to feed to our students in the cafeteria.
These lettuce,
Yeah.
this lettuce here, we started with seed. These lettuce are 2.5 weeks old.
Yeah.
That's how fast they grow in the system. This lettuce is
Yeah.
2.5 feet, and that is
Yeah.
about 4 days old,
Yeah.
something like that.
And this is a little baby lettuce.
Yeah, I'll hold it.
See, what you do is you drop it in these little containers, and this is what we put in so the plants like roots and stuff, they don't dry up, so they won't die. So you put it in here, and after a while when it starts like rotating and filtering out the water, it'll start right here in these little tubes, and it'll find its way down and go through each and every one of them. And eventually when these get to like 2 weeks old, they start to build up their nutrients, and their leaves will get really big. So that way we can make plentiful of lettuce and salads. And if you look back there, and that girl holding the pitcher of lettuce, that's how big the roots can get from all the nutrients they store up.
We have had shipments before with fish in our aquaponics unit, which is in the next room over in our shop. But this is the first for our new unit that our all-tech team has won. This is the first shipment of fish that we've had for that. I would say we had maybe 3 shipments now. We had one before COVID, but those fish died because we were not here to take care of them, so we had to get those out. And then we got a new shipment, I would say, maybe last year, the middle of last year. And so these are the ones that now we're getting some new fish for them in there. And then this is our first fish for the new system that we have now.
I was actually one of the people that unloaded the fish, and I was a little bit shocked at first, because what I had believed was that the fish were going to be like full size, big, giant fish. But when I saw them small, I was like, okay, this makes a little bit more sense, because we can actually watch them grow, watch what we're doing to them. Because if you buy from a company, you don't really know what's going on with the fish, if they're stressed, if they're not stressed, if they're being fed enough. You don't know any of that. But since we bought them like as fingerlings, we understand that, hey, this is what we're doing wrong. We need to fix it.
So you guys remember when Brady told you about how to eat right? Yeah. Okay, so if you look up there, those numbers we see, so what that tells us is the food. Okay, so right now, it's got 1,130 parts per million. So what I know is that's too much food. That's not good. It's concentrated. So let me give you an idea what that means. This is what my students know. So let's pretend this bottle of water is our water reservoir down there. Okay? So what happens is, as evaporation, as the plant drinks, it actually takes water out of the system. So when we start losing a lot of water, we're going to pretend that this is food. So if we don't have a lot of water in the system, it gets very diluted. Okay, see how dark that color is? Now if you took a drink of that, would it be real strong or would it be real weak?
Yeah.
It'd be real strong, right? So if we took and we had a full reservoir of water, like this one does, and we put our food in, and we shook it up, is it going to taste better? Look at the difference in the color. See how light that is compared to that, right? So when you even it out and you got more water in it, it actually will bring that number down, and it'll make it better so the food's more dispersed in the system so our plants don't overeat, okay? Now, that second number is pH. So if the pH isn't right, the plants will have the food right in front of them, but they can't eat it. It won't allow them to eat it. So we got to keep that number in the right range. So if our nutrient numbers are really high, our pH is going to be really low. So we have to make sure that stays balanced out. Like right now, we got to add some water. We're a little low on water, so our ppm's up, our pH is down, so we got to add some more water. Okay? Now, one last thing I'll show you with this system is the lights. We can make these lights really dim, or we can make them really bright. We run these at about 75%. That's what we've done experimental-wise. That's how we know what works right, okay?
I believe that our students at John Hardin, we are going to proceed, we're going to make sure that the ammonia levels and bacteria levels stay normal so that the fish don't create too much ammonia and they basically kill themselves. And then I think what Mr. Hall, what he is going to do is he's going to have us he's going to have us go through a routine probably once every 2 weeks. We're going to filter out all the waste from the fish, and then I think once we do that, we're going to pour in healthy bacteria to make sure that the bacteria levels stay down and controlled.
We are passionate people, and we make sure everyone is welcomed, because yes, it is a great thing that we want it, but we wanted to make sure that it's not competition. We're here to help everyone, because that innovation challenge was to find a problem in our community and solve it. So it wasn't something where, you know, we had it was competing, but we want to make sure we're team players. And so once we got the grant, I think at the moment we were all excited, but it's not really pressure, but ambition. You know, it's something where we can keep growing from that. Because if we can win those grants if the community is already now opening their eyes to that stuff, it's kind of good that we have that out there, because now they're seeing our problem, and it helps us get more grants and get more stuff to build more stuff. Now it does put a lot of pressure, because we got to find room. I think we're to the point where we're just going to build something outside and make it work. But hopefully we can work out some things with maybe find an empty classroom and hopefully get those. We can put more systems in, because we love the shop and we love the lab, but I think it's now to the point where our community has helped us out, our peers, our administration here at John, that I think everyone's ready for it to grow so much bigger than what it is right now, and expand to, who knows, the rest of Kentucky, out in the states surrounding us, or the whole world that we can help out.
This is the project I did for my freshman, or for my first trimester. These are bucket systems. So, kind of how Coach Hall was explaining, you put water inside these buckets, and you put nutrients inside them. And you put this little rock wool in a cup, and you put it inside the bucket, and then water will come up from below and feed this plant. Usually we do tomatoes here. And for our project, we wrote down data for it. Basically, we track pH, nutrients, and temperature. So you can see here tomatoes, this is the pH range we should have, and this is the parts per million range we should have as well. So you kind of have to balance it out, because if there's less water in here, there's going to be more concentrated nutrients and less pH. At the end, they had great growth, and you could start to see the big plant forming. And it was a great project, and you got to learn a lot about how these work. Our project was aeration, which Coach Hall showed over there.
See little air stones here?
We did 2 with aeration and 2 without, to see what they did. And what it seemed like was, without aeration, it was more concentrated in one center of the plant, while aeration, the nutrients was all around the plant.
The program is based off, that motto, living to serve. And so I think that everything here is not just, it's not a grade, it's not something that we have to do, it's something that the kids want to do. It's every time we have, even if we have to clean, re-clean the systems after our harvest, everyone loves it. It's a team effort, and it's really become a thing where everyone is seeing this issue, and everyone is just seeing how, even if we have our different backgrounds or different, atmospheres in life, it shows that we can come together and we can make something really great.
In 2050, supposedly, the world completely runs out of food. This is not a local or a race or age or rich or poor. This is a global problem. It don't matter if you're rich or poor, white or black. It's going to affect everyone. This is going to be one of the biggest world problems that we're going to have. And I believe that aquaponics and hydroponics can fix that problem.
So this is how we actually get all the plants going. So Remember how you guys said we needed soil to grow the plants, right? Well, we can't grow our plants with soil, so what we do is we have this stuff, we call it rock wool. It's, Audrey's going to pass some of it around her and Braden. You can feel it, kind of see what it feels like. But it's kind of like just like styrofoam, not sort of styrofoam, like insulation is what it feels like. It's kind of squishy. And the only thing it does is it just holds the plant, okay? Soil does hold the plant, right? So that's all this does. It doesn't do anything but that. You've got to seed this very carefully. There's a certain way that you have to seed these things. My crew have came up, they actually have a specific way they do it. We're going to let Landry, because Landry is my resident seeder. She seeds more plants back there than probably anybody. Landry is going to explain to you guys how we actually seed the plants, okay?
So basically how we basically grow, we have to have these little tiny seeds, and then we have to take a pencil, and you're probably saying like, why do you not take like a different kind of tool that's actually a plant tool? If we do that, like it will like kind of hurt the seed maybe or something, and then like if we put it back in there, it won't grow as awesome. So we take
So what she's saying is we take a pencil and we dip it in water and get it wet. Because what it allows us to do, we can just put it in there and the seed will stick right to the pencil eraser.
And you have to try to put the seed right in the middle.
Yep, see how it kind of sticks to it? And the key is, you got these little holes in it. You got to put the seed directly in the middle. Why, Landry?
Because if you don't put it in the middle and you put it like on the side, it won't, the roots are like,
They'll grow sideways.
Yeah.
We want the roots to go what direction? Down. So if we stick the seed on the side of the rock wool, they grow out to the side. So we have to make sure we put it straight in the middle. So Landry's showing you exactly how she does it. She puts it right down, does a half a twist, pulls it out. Now what we also like to do with this is we'll take a flashlight and we'll kind of check it and make sure we got it in. And then once it's in there, then we move on, okay? So she'll do a couple of those, but what Emma's going to explain to you is once we do that, once we get them seeded, what the next step is.
Yeah. What we do next is we have to put saran wrap over it.
So everybody know why we put this over top of our plants? Exactly, so we don't dry out. So when we're trying to germinate them, we want to keep as much water in there as possible. So we will take this, wrap it over top of our tray, and it'll hold the moisture in. Now, what we didn't show you guys back there, if you look at that table, there's a blue mat laying there. What we do is, that mat's temperature controlled. So we'll set our mat on 68 degrees, so it keeps a constant temperature under it. We'll wrap it into there so it doesn't affect it. Our plants will germinate in about 2 days. They'll come up doing that in about 2 days. We'll pull the saran wrap off. We'll put it under some of our grow lights for about another 2 days. So in 4 days from the moment we plant our seeds, they're going in our systems. Because then they'll be up about that tall. Anybody know when do you transplant? Does anybody know when? Right, you want the length on them. What we look for is 2 leaves. We want 2 true leaves to be emerged. Once we have the 2 true leaves, then we know we're good and we can go ahead and transplant them over. So that's what it looks like when we got the saran wrap on them, and it'll hold all the moisture in it until we get it done. Now, if they're taking a little bit longer and we see that maybe that they're a little dry, what we'll do is we'll take one of these sprayers, okay, and I'll spray them in the bucket. But we'll just kind of mist them. We don't want to put a lot of hard water on it because it'll break them at that. But that usually doesn't happen. Every now and then it will, but usually it won't. And that's how we keep everything rotating around, okay? So we keep everything rolling. So when we got plants growing in the system, we're getting these ready. When we harvest, we got plants ready to go in, and then we're seeding again. So we keep it rolling all the time. The lettuce system, every 30 days we produce about 90 pounds of lettuce. It's a lot of salads. On our basil system, every 20 days we can do somewhere between 70 to 80 pounds of basil. The fish tanks in 1 year's period, we will produce somewhere in the neighborhood of about 1,500 pounds of fish. So it's just a constant sequence, a constant rotation that we're going to do all the time.
Basically, if you're using aquaponics in the agriculture business, what you would do is you would take tilapia or fish and you would put them in a tank and you would use their ammonia and their feces to use for plants such as cabbage, lettuce, tomatoes, all of that, and let it filter through the system, and then let it feed those plants, and then and the plants feed the water, and then which gets passed back into the tank, which gives the fish a habitable area.
I actually had a project in middle school for VEX robotics, and our mission was to have sustainable life in space. So I got really into the hydroponics then, so the astronauts could grow food and lettuce at the same time to have a sustainable live food source.
The learning curve that I've learned from this was basically how to commercially distribute it to Warm Blessings, Feeding America, all these other donation organizations and helping others. It's really grown my perspective of the world.
The most important thing that I've learned as a student working in the STEM labs is how engaging students actually are with everything here. Like, they all want to participate, they enjoy participating, and they learn a lot, and then they also get to help each other out with their experiments that they get to do.
What we're going to do is I'm going to let you guys ask my team any questions that you guys came up with out there, anything you're curious about.
So the question is, would the fish be able to survive if there wasn't all the stuff we put in, like the nutrients and all that stuff, for it to be able to go?
So like the filter systems?
Yeah.
Well, no, because if the water that they had, the fish poop and its pee, it would just basically go back to the tank and it would eventually kill the fish, because all that dirty water that goes back in, it won't help the fish, it'll just make it worse.
Do some fishes die in the tank?
Yeah.
Yeah.
Yes. So we do. So when we have like our baby fish, when we get them in, we will have a couple that do die, but it's very like with this harvest we've actually maybe one.
Yeah.
I think we've only caught one that has actually died on us.
So I'll follow up a little bit on that question. Here's one of the things I want you guys to always remember. When you do things like this, when you're trying out new things, it's okay to fail. Failure is not a bad thing if you learn from it, okay? So I'm going to tell you, I don't care to tell you this. The first time we ever tried this was about, 4 years ago? And we killed 121 fish in 2 days. And we didn't know what was going on. But here's the thing. We looked at it. We didn't get upset about it. My team looked at it. We figured out what we did wrong, and what do we not do anymore? We learned from our mistake. We never done it again. It was an honest mistake, and we learned more. So when you do farming, any type of farming, whether it's fish farming, whether it's cattle, pigs, whatever, you're going to lose animals. Okay, and sometimes you just got to expect that. Now with our new fish, the 200 we just put in there, we can expect about a 10% loss in the first 2 weeks. That's just the nature of it. So far, we're doing really good. Of the 200, we've only lost one. And now we're kind of past that threshold now. So we're looking really good. So it's going to happen. It's okay as long as you learn from it. Okay?
How long does it take for the plants to be fully grown for ready for harvest?
Lettuce is at least 30 days, especially on the Nft system. It's like about 30 days.
Yeah, so basically 1 month. But whenever you have like how Benny was like saying, if it's basil or not, basil can take up to less because it's a smaller plant. What plant takes the longest to grow, and how long does it take?
It's kale, isn't it?
Yeah, I think it's kale.
It's kale, and it takes about 2 months. Yeah. Kale, it takes about a little bit over 2 months, and it's kale. The ones I was showing you guys in the grow bed with the aquaponics, that takes really long to grow. That's why it's such a bigger tank, is because all those nutrients in it.
How long from a fingerling will it take to become a full-grown fish?
It takes about
3 months.
3 months.
Yeah.
Yeah, 3 months, and we cycle them out 4 times a year.
Yeah,
So
3
there's
months
12 months in a year. It takes 3 months for them, so that's 4 times new fish go in the tank, and that's 4 times we harvest them and give them to one blessing. That's over 200 times 4.
That way, like,
It's
kind of like overlapping, so we're never in like a dead period,
almost-
and we're not producing any.
we serve over 1,000 pounds of fish per year.
Why do you only use tilapia?
So that is a very good question. So we actually, I'm gonna scoot by you all. We actually have used other fish before. We use koi. Yes, we use koi, and so why we use tilapia, do you all wanna explain that?
So the reason why we use tilapia is because, first of all, they like grow really fast. For a fish to be like fully grown in 3 months, that's a really fast time. And they can also like sustain in really dirty water. So we don't have to like constantly like keep on checking the water, making sure it's like perfectly clean. Like if you have a pool, you have to keep the water perfectly clean so you can swim in it. But with tilapia, you don't have to, and they can sustain like dirty water.
How old? That's a really good question.
A fingerling is 0 to 3, around 0 to 3 weeks. And then once they get, it's more by weight, so in length. So once they get a little bit over right around an inch in length, then they're called fries. And then after about 2 inches, then they're called just regular tilapia.
Where we find the fish, so we actually partner with a college, and so is it Kentucky State? Kentucky State University. We actually partner with them, so they help us back here. So if we ever have a problem that we don't know how to fix, we can call them and say, hey, do you know how to fix this? Because they had the same thing at their school. And so they actually donate us the fish, and we actually have a great partnership with them. Her question was, can plants stay with other color light? Actually, when we do experiments with different lights, you can use different lights for certain vegetables and stuff. We just found with our lettuce that the bright white lights actually help a lot with them.
Okay, why do we do this and not just buy a greenhouse?
We do have a greenhouse, but our greenhouse, unfortunately, we are not using because it's hard for kids who can't be able to walk down there. It's very hard to get down there. And so actually we are looking to buy a new greenhouse. And so we are actually going to get a new greenhouse very soon.
And another problem with greenhouses is that it gets so much sunlight, it actually with the plastic will warp it and cause us to not have good fitting, so we'll leak water a lot. So what we found, because we used to do it in our greenhouses, it actually works a lot better where we can control our environment better in here than down in the greenhouse.
Has there ever been a parasite or disease that our fish have had so far?
Good question. No, there hasn't been, but it's very easy to happen. So if you go to a big commercial aquaculture, aquaponics system, what they'll do is they'll actually make you disinfect your feet and your hands before you even walk in. But we've not had that problem. Doesn't say it won't happen, but we've been very lucky so far. We've not had anything like that happen. That's a really good question.
If there's one thing that if you ever want to learn from this or what you should know about our program is it's not just a program where we have just students coming in to help. We're not just getting money for all this, and we're not just building it for press or anything. It's the community. We are here for the community. As an FFA member of the organization that agriculture is based off of, we always have a motto. It's called, part of the motto is living to serve. That is our motto for what we do here. We have a culture of excellence that our chapter team and our officer team follows, and it carries on to our agriculture programs, and it shows that yes, we might have these monies coming in, we might have the press, we might get some pictures and stuff, but all of this is for warm blessings. All of this is for our kids in the school that can't get the proper food they need, and some of them that maybe not eat at all because some places still don't do free or reduced lunch in some counties. And so giving that stuff back to our community is the main thing I want to take away from this and tell people that we are growing for a new future. We're growing for a new future in our community, in agriculture, and with our students. And you can see that with opening the eyes of them wanting to come in and help, even if they're not in ag.